Good morning. I'm on the way to the gym again, so it's time for another Cloudbit. So today I'm going to talk about Apache tools like Hadoop and hdfs and some other tools. And basically a lot of people think Hadoop is an old hat technology because they haven't heard of it much lately, that kind of thing. Well, actually I've got news for you. So Apache is really the leading open source provider of software. So many really good software engineers love Apache because everything's open source. That means that lots of developers have contributed to the software. It's a really good program for developing software, and a lot of really good software engineers really like it. So Apache have this set of tools that we call Hadoop, and they all sit on top of hdfs. So hdfs stands for Hadoop Distributed File System. So what's a distributed file system? A distributed file system basically means all of the files can be stored and processed on different servers. So you can have multiple nodes or multiple servers or multiple computers all configured to work together. And what it means is that you can get a lot of speed and parallel processing done using hdfs as the underlying technology. So hdfs is usually the underlying technology below all the other Hadoop tools. So what are the other Hadoop tools? So tools like Hive and Pig and Spark that you might have heard of are tools that sit on top of hdfs. And there's also a NoSQL database, and that's one of the best parts of it, and we'll talk about that in a second. So what are Hive and Pig? So Hive and Pig really allow you to kind of manage and process SQL-like data files. So it's almost like saying, I've got some files, let's convert them into almost like SQL tables, having like rows and columns kind of thing, and use them as if they were SQL and do some processing on them. So you might have heard of MapReduce. So MapReduce is kind of used in between the hdfs and the Hive and the Pig to basically reduce the amount of data that you're processing pretty much. So what it does is it kind of maps the actual columns that you're interested in from the files that are the source, and then it just filters those out by particular criteria. So that's what map and reduce means. So map is pretty much, let's just map the columns we need, and reduce is pretty much, let's filter by the criteria that those columns need to match on. So for example, if you've got lots of orders in a file, you might only want the order ID and the name of the person ordering, and you might want to filter by date, for example. So you only want today's orders, okay? So MapReduce would only select those columns that you said you wanted, like the order ID and the name, and would then reduce the number of rows that came back to only the rows that you want for that date, okay? So that's kind of how MapReduce works. It's a little bit more complicated than that, but you can think of it as that. And there is a Hadoop database, which is a NoSQL database. It's had a few different names, and it sits on top of this whole MapReduce mechanism, and it helps you to process that data. So those tools all work together in the Hadoop environment. Now, what's this got to do with the cloud? Well, first of all, you can take all of the Hadoop suite of tools, and there's a lot more. There's things like Zookeeper, Mahout. Mahout is for machine learning, and Zookeeper is really a way of managing everything and keeping everything in line. If you think of a zookeeper, keeping all the zoo animals in line and keeping them kind of working together, coordinated, if you like, that's kind of what Zookeeper does. It kind of manages the systems that make up the Hadoop system and the data that makes up the data, and allows you to manage everything. It's kind of like a bit like a mesh, a bit like an Anthos, but just for Hadoop. well, actually, you can use Zookeeper on lots of systems, but when we're talking about the Hadoop systems, we're talking about that one, the Zookeeper one. So that's kind of how they all work together. Now on the cloud, you can use all of the Hadoop suite of software, and there's lots of these. I've mentioned most of them, but there's a lot more. I've mentioned most of the important ones, I should say, but there's a lot more. So on the cloud, you can nearly always install them directly onto like a server or a virtual machine or what have you in the cloud. That's one option. They nearly all have marketplaces with Hadoop tools easy to download onto your servers within the cloud. So that's one option. However, all three of the main clouds have a way of using the Hadoop suite of tools embedded into the cloud technologies, and a lot of the cloud technologies are built on top of Hadoop stuff anyway. So for example, Google Cloud is the one that's most close to the original Hadoop and taking it up a little bit further. So there's things like Dataflow, which is set on top of Apache Airflow, which is another one of the Apache tools. There is like a NoSQL database called Bigtable, which is pretty much based on Hadoop database. The NoSQL database, it's kind of like a columns only table format kind of thing. So that's pretty much JSON, usually a packet of JSON in each column. And then there's all of the clouds, I think, have a way of embedding a Hadoop mechanism into their processing. So there's like data pipelines, and most of the data pipelines are built on top of Hadoop type tools. Most of them, all three of the main ones, have a Spark version that you can use within the cloud, or a tool that is built on Spark. Now Spark is another Apache tool that sits on top of Hadoop. Spark is for batch processing in memory, so it's really fast at batch processing data. So if you've got a ton of data coming in and you put it into a data lake and you want that data lake processed really fast, perhaps with parallel processing, then Spark is probably going to be a good option for that. And there's something called pyspark, which is Python Spark, which is basically Spark that you use Python programming language to do the processing. So a lot of people really like pyspark because the language is nice and it's so fast and so on. So that's kind of the options, and in all of the clouds you have these kind of options. So EMRFS in AWS. EMRFS is Elastic Map Reduce File System. That's a mouthful. And it's based on Hadoop, basically. It's on HDFS. And you can use all of the Spark tools, all of the Hive and Pig, all of the Apache tools on top of all of that. So you can use all of the Apache tools in that EMRFS environment. In fact, if you want to, EMRFS can actually use HDFS as its file system. So you've got an option when you set up EMRFS in AWS. They give you a choice. Do you want the EMR version or do you want the Hadoop version? And theoretically, the Hadoop version is kind of a little bit older and the EMR version is a little bit more modern and so on. And gradually those two versions are getting further apart. But some people just prefer to stick with Hadoop because it's open and then they can move from one cloud to the other. So that comes to the other reason why people like the Apache toolset. So because it is open source and it works on all the platforms, so it works on-premise, it works on all three clouds, it works on any cloud, it works on any server, and it's designed to be that way. Because of that, a lot of people really like it, especially in a multi-cloud environment, because the same code can run in three different clouds and on-premise as well. And also because they can then they're not like locked into a particular cloud vendor. So if they want later on to go from Azure to AWS, they can do. If they want to go to Google Cloud, they can do. If they want to go to all three clouds, they can do, because it's really easy if you're kind of building everything on top of Hadoop to make that code work in all three environments and in the on-premise environment. So that's some really good reasons to use the Apache toolset. This is the Cloudbit for today, and I'll see you next time. Thanks.